Welcome you all. In this session, we are going to see about scattering of light. What is scattering of light? Scattering, that is, a deviating, bombarding on a particular particle and then coming out. And this is the basic concept of scattering. Scattering involves two or more particles and that of the light particles, that is the light photons. Light photons interact with the particles in the atmosphere, then it will be scattered. Now you can easily understand what is scattering of light from the definition. When sunlight enters into the Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere refract, note the point, refract the light in all possible directions. See, the sunlight falls on the particle, then it will be scattered. One particular particle is seeing stationary here, but it is moving always. When light enters into the atmosphere and refracts other particle, then the different rays emerged from the particle, and then each and every rays contains different wavelength and different frequencies. Okay, what are the types of the scatterings? When a beam of light interacts with a constituent particle of the medium, it undergoes many kinds of scattering. Based on the initial and final energies, we can classify the scattering into two types. One is the elastic scattering, the other one is the inelastic scattering. Okay, based on the energies of the particles occurring, we can classify types of scattering into two. One is elastic scattering, the other one is the inelastic scattering. What is elastic scattering? You can take this particle. When light rays strikes these particles, then if you analyze the energy of the emerging ray, if the incident ray and the emerging ray contains the same energy, you take initial energy as E1 and final energy as E2, then E1 is equal to E2. Then this type of scattering can be called as elastic scattering. Initial energy is E1, final energy is E2. When you calculate the energies of both these rays, then these two energies will be equal. What is inelastic scattering? If the energy of the incident array and the final ray are not the same, then you can call this type of scattering as inelastic scattering. You take again the initial energy of the ray E1 and the final energy of the ray E2. After bombarding, E1 is not equal to E2. Then you can call this type of scattering as inelastic scattering. Okay, initial energy E1, final energy E2. Calculate these two, and E1 if not equal to E2, then you can calculate, then you can call this type of scattering as inelastic scattering. Depends on the nature and size of the scatterer. The result in two different types of scattering can be classified as a Rayleigh scattering, Mie scattering, Tyndall scattering, and a Raman scattering. Let me explain one by one. What is a Rayleigh scattering? Then if the instant beam strikes the particle, then it will be scattered in different directions. And the amount of the scattering, know the point. What is Rayleigh scattering? A Rayleigh scattering, the scattering of sunlight by the atoms of molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. The definition of Rayleigh scattering is same as that of the scattering, provided that we have to note down one important point, that is, the amount of the scattering is inversely proportional to the fourth power of the wavelength. Amount of the scattering is inversely proportional to the fourth power of the wavelength. Okay, this is called as a Rayleigh scattering. When sunlight passes through the atmosphere, the blue color is scattered to a greater extent than the red color, so that the sky appears blue. Now you can analyze why sky appears always blue in color, because the lower wavelength particles are scattered away, okay, so that the sky appears always blue in color. This is due to the shorter wavelength of the particles, light particles. Okay, see here only the lower wavelength particles are scattered in a large amount so that we can easily analyze. The sky appears blue in color. Why the sky appears blue in color? Because of the waves, scattered waves contains lower wavelength. During evening, that is, at sunrise and sunset, the light rays from the sun have to travel a longer distances. Okay, from the atmosphere than at the noon. At the noon, they are traveling only shorter distance, but during morning and evening, the waves should travel longer distances. During this travel, that is only the red light gets least scattered and then reaches the earth. See in this picture, the sky appears red in color during morning and evening. This is due to larger wavelength. Red light possesses a larger wavelength. It has to travel a larger distance during evening and morning, rather during afternoon. During afternoon, it has to travel only compared to shorter distance than evening, so that the sky appears blue during other time, and during morning and evening it appears red in color. What is Mie scattering? Mie scattering, you consider the initial array contains one particular wavelength. If the wavelength is greater than or equal to lambda, that is, you consider the diameter of the particle. If the diameter is greater than or equal to wavelength of the incident particle, then Mie scattering occurs. Now, I hope you understand the concept. The wavelength of the initial particle is lambda if this wavelength should be smaller and d should be greater or equal. Okay, see in the sky, the clouds are always white in color because of the particle water droplets present inside the clouds having greater diameter than that of the waves entering into the sky. See here, so that all possible colors are scattered at a particular time and they are combining and produces white color. We know the white color is the combination of all other colors because the diameter of the particle is greater than the wavelength of the incident ray equal to or greater than the wavelength of the incident ray, it scatters all possible colors combine together and forms white light. This is Mie scattering. Then come to the case of Tyndall scattering. The scattering of the light is by the colloidal particles in the colloidal solution is called Tyndall scattering. You can see the ray of light enter into the window because the particles, dust particles in the atmosphere scatter all those particles and the path is visible to us. Okay, this is due to Tyndall scattering. This is due to Tyndall scattering. See, when a flash of light passed into the solution and a colloidal solution, what will happen? In the true solution, you can't see the path. But in the case of the colloidal solution, you can see the path of the light. This is due to the scattering occurs in the case of the colloidal particles. The size of the colloidal particles is somewhat greater than that of the particles in the true solution, so that the path is visible in the case of the Tyndall scattering. Okay, when you pass the light, then the path of the light is not visible in the true solution, but it is visible in the colloidal solution. This is due to Tyndall effect. What is a Raman scattering? Raman won the Nobel Prize in 1930 for physics. And one more additional information is that he discovered the Raman effect. And besides discovering a Raman effect, he studied extensively the X-ray particles diffraction and in particular acoustics optics. He won the Nobel Prize for physics. Now, what is Raman scattering? You consider a monochromatic light. A monochromatic light is a light which contains all possible wavelengths and energies. Okay, when a monochromatic light passed on to the particle, that is, if it's scattered with a particle in the atmosphere, then you can get two types of rays which will emerge from the scattering. Then, what are the rays? The ray may contain a lower frequency and the ray may contain higher frequencies. The rays which contain lower frequencies can be called as Stokes lines, and the rays which is having higher frequency can be called as anti-Stokes lines, which is denoted in different colors here. See yellow color and orange color. Yellow color related to lower frequency, that is the Stokes lines, and orange color related to the lines containing higher frequency, that is anti-Stokes lines. Okay. Initially we are having one particular color, is it not? Then with the same wavelength, that is incident, will be emerged. Those lines can be called as a Rayleigh line. And the lines which is having different frequencies can be called as Raman line. The incident array contain one particular wavelength, and we can have the same wavelength after scattering, and these lines can be called as a Rayleigh line. Then the different frequency lines, that is the lower frequency line and higher frequency lines, can be called as Raman lines. In particularly, lower frequency lines can be called as Stokes lines and higher frequency lines can be called as anti-Stokes lines. Now, I hope that you are very much clear about the Raman scattering. Okay, the incident ray, when it strikes the particle, then it will give different types of rays. One type of ray containing the same wavelength as that of the previous one, the other two containing different frequencies. Thank you very much for watching.